Hello. Today we begin Unit 3 of our course. And in Unit 3 we will be discussing electricity. So let's start with a discussion on electric charges. Electricity is fundamental to nature. What does that mean? It means everything that the universe is made up of contains electric charges. In fact, the three fundamental quantities that make up the building blocks of the universe are mass, charge, and spin that determines the symmetry of particles. So electric charge is a fundamental quantity in nature. Now atoms, which are the basic constituents of all matter, is made up of electrically charged particles. I'm sure most of you know what these electrically charged particles are. Now this is the classical picture of an atom, where you have a nucleus that contains protons. Protons carry a positive charge, and electrons that is in a cloud around the nucleus carries negative charge. Now what is the special characteristic of an atom? An atom carries two types of basic charges that are present in the universe, and that is a positive charge carried by a proton and a negative charge carried by an electron. Now the amount of positive charge carried by a proton equal to the amount of negative charge carried by an electron. So if you keep a proton and an electron together, there will be no net charge. When there is no net charge, we say the object is neutral. An atom in the normal case is a neutral object because it contains equal amounts of positive and negative charges. Protons, which are found at the core of the atom, carry a positive electric charge, and we represent that by the lowercase e. And these protons are fixed to their relative positions. You see, you can see electrons are free to move about, but protons are fixed to their relative positions. So, when we talk about motion of electric charges, we actually mean motion of negatively charged electrons. Alright? Positive charges or positively charged protons are fixed to their relative positions and they do not move. Electrons are found moving in the space surrounding the core of the atom, and they carry an equal and opposite amount of charge, negative E. Well, this is another picture of the classical atom. Well, this is really not the picture, the true picture of the atom, but for our purpose, the classical picture of the atom is good enough. Alright, so E is the fundamental unit of charge. What does that mean? E is the fundamental unit of charge. It means all other charges come in multiples of this E. E is the basic quantity. You cannot divide the unit charge. You cannot divide that any further. So this is the basic charge, the fundamental unit of charge. And this means that charge carried by anything else comes in multiples of E. A proton and an electron together form a neutral object with no net electric charge. What does that mean? This means that the neutral object, although we say an object like this is neutral, does it mean that it contains no electric charges? No. Everything in the universe is made up of electric charges. So when we say this object is neutral, it means it contains equal amounts or equal numbers of positive and negative charges. Electric charge is measured in a unit called coulomb. and we will be using it profusely as we go on. 1 coulomb is actually a very large unit. You divide, so you have smaller units like millicoulomb, which is 1,000th of a coulomb, microcoulomb, which is 1,000,000th of a coulomb, nanocoulomb, and so on. We will be using a lot of these. Microcoulomb, see how you write microcoulomb, μc, nanocoulomb, and so on. Now this is the value of the fundamental unit of electric charge. E equal to 1.602 times 10 to the negative 19 coulomb. This is the charge carried by an electron and also a proton. Charge carried by the electron is negative, charge carried by the proton is positive. Let's do a small problem. A charge equal to the charge of Avogadro's number. We have seen Avogadro's number, is that right? What is Avogadro's number? The number of atoms in 1 mole of a substance, which is 6.02 times 10 to the 23. The charge equal to the charge of Avogadro's number of protons is called a Faraday. So you take Avogadro number of protons or Avogadro number of electrons, that much, the amount of charge carried by that many protons is called 1 Faraday. Now how much is that? Calculate the number of coulombs in a Faraday. Well, if this is the total number of protons in that make up Avogadro's number, and each proton carry what amount of charge? Each proton carries the basic unit of charge, 1.602 times 10 to the negative 19 coulomb. So what all we need to do is multiply the total number of protons by the charge carried by a proton. So the charge of this many protons, each proton carries this basic unit. Therefore, the charge carried by these many protons is the number of protons multiplied by the charge carried by 1 proton. That is 96,440 coulomb. This is an important quantity in chemistry. This is called a Faraday. The amount of charge carried by Avogadro number of protons is called a Faraday, and that is 96,440 coulombs. It's a very large amount of electric charge. Next problem. How many coulombs of negative charge are there in 1 gram of copper? Well, 1 gram of copper, we need to know how many atoms are there in 1 gram of copper. How do you know? Well, we know it from the atomic mass of copper. What is the atomic mass of copper? 63.5 gram. That is the atomic mass of copper. This means that 1 mole of copper is 63.5 gram. That is the meaning of atomic mass. We talked about it in the last unit. So atomic mass of copper is 63.5, means that 1 mole of copper has a mass of 63.5 gram. And 1 mole of copper contains how many atoms? Avogadro number of atoms. That means 63.5 gram of copper contains Avogadro's number of atoms. And what is that number? 6.02 times 10 to the 23. 1 mole of copper contains Avogadro number of atoms. That means 63.5 gram of copper contains 6.02 times 10 to the 23 atoms. Therefore, the number of atoms in 1 gram Can you tell me what that will be? This many atoms are contained in 63.5 gram of copper. Therefore, what is the number of atoms in 1 gram of copper? That will be the total number divided by its mass. And that is 9.48 times 10 to the 21 atoms are there in 1 gram of copper. Well, what is the atomic number of copper? You remember the atomic number of copper? The atomic number of copper is 29. It means each atom of copper carries 29 electrons. Now, there are these many atoms in 1 gram of copper, 9.48 times 10 to the 21 atoms. And each atom carries 29 electrons. So, how many electrons are there in 1 gram of copper? The number of electrons in 1 gram of copper is the total number of atoms multiplied by the number of electrons per atom, and that is 2.7 times 10 to the 23 electrons. Alright, and now you know each electron carries the basic unit of electric charge. Therefore, the total charge carried by all these electrons, which are contained in 1 gram of copper, will be these many electrons multiplied by the charge carried by 1 electron. It's the number of electrons in 1 gram of copper multiplied by the charge carried by 1 electron, and that is 43,254 coulombs. That's a tremendous amount of electric charge. 1 gram of copper carries 43,254 coulombs of charge. In fact, one human body actually carries millions of coulombs of electric charge. Well, all those electric charges are enough to destroy or burn the whole universe. But still, nothing happens. Why? Because these negative and positive charges coexist in a very peaceful manner in our beautiful universe. Isn't that wonderful? Yes. Let's now talk about conductors and